Okay, so for this rewind, what is this figure? It's a triangle. What do you know about this triangle? It has 3 sides. Like all triangles, it has 3 sides. Why do I see 4 lines then? Mauro? The height? Which one's the height? How do you know that? It goes straight to the peak of that triangle, right? So it goes to the highest point of that triangle. And we wouldn't count 9 or 5x as the height because those lines are what? They're diagonal, they're slanted, so they're not straight up and down. Good, so the question in the rewind says the perimeter of the triangle above is 90 millimeters. The first thing says solve for x. So how would you go about solving for x here? So if you were doing the first part of this, how would you solve for x if you know that the perimeter of the triangle is 90 millimeters? 5 and 4? I agree with you, the sides that you're using, but is it just 5 and just 4?
9, 5, 8. Well, yeah,
so if I do 9 plus 5 plus 4, that just gives me 18. Does that just say 5? 5x, right? So 9 plus 5x plus 4x. Why do you not include, I agree, that's perfect. So why do you not include, no, the height we already talked about. Why do you not include the mm? Matthew? Yeah, that's just the unit, right? So if you put it in and you might think it's another variable when it's not. So then what would I do to simplify this? Okay, which would give me what? 9x. So I've got 9 plus 9x equals 90. Keep going. And x equals, good, so we've solved for x. Perfect. Okay, how come I subtracted this 9, but I added these 2 together? Why did I add together the 5 and the 4, but I subtracted this 9? Rodrigo? I'm trying to get 9x by itself. Okay, true. How come I didn't do 5x minus 4x? Okay. But this one's positive and I subtracted it. Okay, do I want to move those to the other side? No, they're staying on the same side, so we just combine like terms. Okay, so then 2 says find the missing lengths. So if x is equal to 9, then what do I do to find the missing lengths? Plug it in. Okay, so this one I already know is 9. What would this one be? 45. And this one? 36. And this one? 27. Good. All right, and then number 3 says find the area. So what would be the last thing that I would do then? Matthew? Okay, base times height divided by 2. Gabe, is that what you're going to say? What were you going to say? Okay, so we're going to, now we use the height though because we're talking about area, right? So which one is the base? 36, and which one is the height? 27. So I'm going to do base times height over 2, or what's the other way I can write that? Half BH. Does it matter which one you use? No, I think it's easier to use the fraction one because then you can make a smaller number. So that's the one I always use. So 36 is our base, 27 is our height. What is half of 36? 18. So I'm going to do 18 times 27. Because I'm multiplying these 2 together. So I take half of this one and then that gives me 18. I'm not distributing it to everything because it's not like they're added together. That's a good question though. Gisela? No, no question? Okay. All right, so 18 times 27. Thank you. All right, why is that 1 millimeter squared? It's area, and so area is always to the second power. Why though? Not necessarily. No, it's not because it's half of a rectangle. Why is the unit always squared? How many dimensions is a triangle? 2 dimensions. So it's squared. Okay? So that's it. The reason it is actually because this is 36 millimeters times 27 millimeters, and millimeters times millimeters is millimeters squared. But the way that I always remember it is that if we're talking about area, we're talking about a 2-dimensional figure, so it's the second power. All right? Whereas if you're talking about a line, that's a 1-dimensional. Okay, so moving on then to what we're talking about today, we're going to talk about midpoint. And we talked about midpoint a little, at the beginning, like maybe the middle of the first week of school. So it's been kind of a long time. Can somebody refresh my memory on what a midpoint is? Go ahead. Exactly, the point in the middle, right? That's why they call it a midpoint, because it is the point in the middle. Is B the midpoint of AC? At first glance, does it look like B is the midpoint? Yes. Maybe. Is it actually? No, why not? It's a little bit closer to C than it is to A, so it's not the midpoint. So what? So Gabe, what would the midpoint be?
1.5.
How do you know that?
But like, because like,
Could you try? You can be.
Because if it's just like, just look at the dashes.
Okay. So what are you doing with the dashes?
Because if you put, there's 3 on that side, 3 on that side, but
Exactly.
you have to go in between the dashes.
Yeah, I think that was a great teaching. So what Gabe said, if you didn't hear him, is he basically counted the dashes. There's 3 on this side and 3 on this side, and then you'd have to go halfway in between to get to the midpoint. So the midpoint there is 1.5. Is there a way that we could find that mathematically? You've got to do something divided by 2, right? Why divided by 2? You're right, and that's the gut instinct is I got to divide something by 2, but why? It's half of the whole, but before you do that, you have to figure out, well, what's the whole? How am I going to do that?
Count how many spaces are between A and C.
Okay, so I could count how many spaces there are between A and C, and how many spaces are there? 7. If I do 7 divided by 2, what does that give me? 3.5. Is that the midpoint? No? That's how far you need to go, right? But I want to make this easier. I don't want to have to do like, okay, now I know it's 3.5, so I move 1, 2, 3.5. Is there a way, what did you do to get 7? You could either count, or what could you have done with these numbers? Subtracted them, right? What if instead of subtracting them, you added them? What is 5 plus negative 2? Equals 3. And what's 3 divided by 2? Which is our midpoint. So to find the midpoint, you take the ends and you add them together and divide by 2. Does anybody have a guess on why we add them? Kind of, yeah. Let me ask you guys this. If you had, let's say you've had 2 tests in a class, and you got an 80 on one and a 100 on the other.
90.
What's 90? Your average is 90. Why? 90 is right in the middle of 80 and 100. So when you're finding the average, how do you do it? Add things together and then divide by the number of things. But in this case, since it's a midpoint, it's always going to be divided by 2. Okay, so when you're looking, 5 plus negative 2. So we added together 5 plus negative 2. Because 2's a negative, you actually subtract them. But is that a hand? Yeah. Exactly. Plus. Mm-hmm. It's the end point plus the end point divided by 2. So we would say midpoint is equal to end point plus end point divided by 2. Don't write this down yet, though. Okay? So keep that in mind, but don't write that down because we're going to change it a little bit. So we've got end point plus end point divided by 2. Now, that's if it's on a number line, but we're not really going to work with them on number lines. We're going to work with them on this thing, which is a what? A graph or a, what kind of plane? Coordinate plane. This is a coordinate plane. What's the difference between this D right here and just being on a number line?
It's a segment.
It is a segment, true. DF is definitely a segment. It isn't, D is an endpoint, F is an endpoint.
It's a point.
You have coordinates instead of just one number, you have how many? 2. So what's the coordinate of D? -3, -3. So it's at -3 on the X, -3 on the Y. I know it's a little bit hard to see. All right, F is at 1, 8. So those are our endpoints. So just to go back for a second, what do we do to find the midpoint? Endpoint plus endpoint, and then divide that by 2. So the only difference here is how many endpoints do I have? I have 2 parts of both endpoints, right? So when you're looking for the midpoint, instead of just doing it once, how many times do you have to do it? You have to do it twice. Go ahead. Uh-huh. Like using like the little sub numbers? Yeah. So we're going to use x1 and x2. All right? So when you're finding the midpoint then, what would I do? What do you think I would add together? 1 and -3 and divide that by 2. And then what else? 8 plus -3 divided by 2. And that's going to give me my coordinates. So what's 1 plus -3? -2 over 2. And then what's 8 plus -3? 5 over 2. Okay. Can I simplify this one? Yeah. To what? -1. And what's 5 divided by 2? 2.5. So our midpoint there would be what coordinate?
2.5. Wait, no, 1, 2.
-1, 2.5. Which if I go back to my graph, -1 up 2.5, that's right in the middle. So that's our midpoint. Okay? So the difference with a number line and how you do it, the math itself, is it any different? No. The math itself is exactly the same. How many times do you have to do it?
Just twice.
Twice. All right? So instead of just doing one value, you've got the x's and you've got the y's. The really important thing, though, is to make sure, like this one worked either way because they had the same number here, but make sure you do your x with your x and your y with your y. So just be careful with that. All right? Similar to when you guys used to do slope.
So the formula would be x1
Plus x2 over y2. Perfect. Yes. Okay, so let's try this one. All right, what would I do here?
You divide it by 2. No, you do a -8 plus 7 divided by 2. And then you do 3 plus -3 over 2.
What's -8 plus 7?
-1.
And 3 plus -3? 0. Can you simplify either of those?
No. Wait, yes, you
Which one? -1 over 2 is the same as -0.5. You could also leave it as a fraction. And then 0 over 2 is, okay. So let me go back and plot that. -0.50
So you basically do x1 plus x2
over
over
2.
y1.
No.
Oh,
x1 plus x2 divided by 2. Y1 plus y2 over 2. Yep. Gabe.
It's hard Spanish and 7 is 0.
That's true. All right, good. Thank you for sharing. Thank you for making it a little more bilingual in here. Okay, so then we don't really need to come up with a formula because Gisela said it and so did Rodrigo. But here's the formula that you would use, okay? x1 plus x2 over 2, y1 plus y2 over 2. Does the order of the x's and the y's matter? No, because when you add, order is not important. But you've got to do your x's together and your y's together. Okay, so when you're calculating a midpoint, you add them together and divide by 2. Okay, take 3 minutes, and I want this row to do number 1, this row to do number 2, this row to do number 3, and this row to do number 4. So what would be different? Mauro, sorry. Yeah.
When you're doing these like this order, how could you, when you're doing the first, the -4, like that one,
Uh-huh.
how come you do -4 and 5, but then when you're doing the other one, you have to start with the other one?
You don't. You can start with either one. Yeah, it doesn't matter because it's addition, so the order doesn't matter. So whichever one you'd rather start with, whatever makes it easier for you in your head. Because sometimes it's easier to do like 5 minus 4, 3 minus 1 might be easier in your head. So then just do it that way. Okay, good question. Yeah, order does not matter here. Okay, what is different in this picture? This says, can you find the other endpoint of a segment if you know one endpoint and a midpoint? So what's different here? Matthew? Yeah, you have to find the other endpoint. So this right here, is this an endpoint or a midpoint? This is an endpoint, and this is a midpoint. So where's your other endpoint? Somewhere off up here, but I don't know where it is. So does anyone have any ideas on how I could figure it out? Pedro? Okay, so it's probably going to involve multiplication, right? Because what we did before was divide, so we're probably going to have to do the opposite. That's good. That is good algebra. So how are we going to do that? So let's take a look at x. Remember that our formula is midpoint equals, I'm just going to simplify and just put x1 plus x2 over 2. I'm just going to talk about the x's right now. All right? So what's my x from the endpoint? -7. Where would that go in here? x1. So this one would be -7. Do I know x2? No, because that would be my other endpoint. I don't know what that is, so I'm just going to leave it as x2. I'm actually just going to write it as x. Still over 2. And then do I know my midpoint x?
Yes.
What is it? 1. Where'd you guys get that? It's right there. This is the x in your midpoint. So here is this equation. What can I do now to figure out the other x? Cynthia? Okay, so the x values, this was our endpoint, so it's -7. And then the midpoint, the x value was 1, so it's 1 down here. Does that make sense? Yeah? Okay, so then how would I get x by itself here? I can't add 7 yet. I'm going to have to add 7, but I can't do that first. Multiply by 2 first. So like Pedro said, I need to multiply by 2 because this means what? Divided by 2, so to get rid of it, I multiply by 2. If I do it here, what do I have to do over here? Okay, if I multiply by 2 here, I have to multiply by 2 here. 1 times 2 is 2. And now this is gone, so what do I have left? So then, Matthew, now what do I do? Add 7 plus 7, and what does that give me? That goes away. X is equal to 9. So that's our x coordinate. But I can't just plot an x. I also need a y. So what would my formula look like for y? Same thing, except instead of x's, it would be y's. So midpoint equals y1 plus y2 over 2. What's the y midpoint? -1 equals, what's my y1? -8. Do I know my y2? And then I do the same thing. What's the first thing I do? Multiply by 2. What is 2 times -1? And then what do I do with the negative 8? 6. So then my coordinate is 9, 6. So I'm going to plot that up here, 9, 6. And that's my other endpoint. Now, how many people got lost in the algebra there? Yeah, like I love algebra, and I want you all to love algebra, but it's okay if you don't, because that's a lot of complicated, maybe not the right word, but that's a lot of algebra to do. So I'm going to show you another way to do it. If you like the formula, if that makes sense to you, by all means stick with it. I don't ever do it that way, because I don't think it's the easiest way to do it. So I know that this is my endpoint right here. Can I figure out basically how far I have to go to get to my midpoint? Yes? How? By counting, right? How far over do I have to go? So I'm just going to count. I'm going from negative 7 to 1. So I go over 1, 2, 3, 4, 5, 6, 7, 8. So how many over did I go? I went 8 over. And now I have to go from negative 8 up to negative 1. So I'm going to go 1, 2, 3, 4, 5, 6, 7. So how many up did I go?
7.
So I went 8 this way and then 7 up. So if I want to find the other endpoint, what could I do? Go 8 that way and then 7 up. Okay? So what I am right now. All right. So I'm going to go 8 over 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7. And then I end up at the exact same place I was before.
Can we do this for every endpoint, midpoint? Does it always work this way?
Yes. Like, can you always count it? Yes.
How come you just don't do that instead of all this extra?
Because I like to provide you 2 ways to do things.
Oh, just you can't figure it out.
One a mathy way, one a county way. All right. So when you're finding the midpoint, I tend to think that just adding it together and dividing by 2 is pretty easy. When you're looking for another endpoint, I usually just count it. Because does this make more sense than this to some of you guys? Okay, and if that's what makes sense to you, that's fine. There are some people who this makes a lot of sense. I really like algebra. That's why I teach it for a living. So I like doing it this way. But I know, I also teach algebra. Okay. So I like doing it this way, but if you don't, then don't. Just count it out. Gabe?
I have a question.
Yes.
So basically, so what if you did all the way over and all the way up, right?
Well, how do you know how far all... Oh, okay, sorry.
Like, see the corner, like the corner of like little, like this, like go all the way over,
Like here?
then go up,
Okay.
but your little corner
Uh-huh.
is that, like, go to your corner,
Oh, don't put me in a corner.
then go diagonal,
Okay.
like go diagonal, no, the other way, like this way. Yeah.
Oh.
That equals-
Oh, like could you count the other way?
Yeah,
Yes.
to make your midpoint.
Yes.
So I can do that with endpoint.
Yes. Like, can I go back to an endpoint problem and see? Okay, so let's go back, because I think I know what you're saying. So what you're saying is like for one of these,
Yes.
could you have done the same thing? Could you have said, okay, I'm going over this many and up this many. Well, what if I went only halfway and halfway? Could you do that? Is that what you're saying? Like, what if I went, okay, if I know this is, you counted and it's 15. So if you know that's 15 and you know that this is 6, could I have done it and just gone halfway of 15 and halfway of 6? Yes, absolutely. Like, could you count this way too?
Yeah.
Definitely. I just think, let me rephrase. In my experience of students doing this, I think, it's just, I think people they do this and don't ever get it wrong.
Oh.
So I don't think, like, how many of you guys understood this and were like, oh, I just add and divide by 2, right? So, well, that's impressive that 2 of you just raised your hands. I'm going to assume people didn't hear the question. But people don't usually have trouble with that. It's the endpoint, midpoint one that people struggle with. Okay, but yes, Gabe, do whatever you want. Cynthia.
When we have like homework or
Mm-hmm.
and we do that, but instead of just putting the lines and counting,
Uh-huh.
and I just put the number on the paper.
Yeah.
Is that okay
Yeah.
Or do you, I just
If the number is right, the thing is, like, if you have the right number, I'm going to assume you did it right, right? So, yeah, I don't care how you got there. No, because there's problems where you have to show your work. If I said, you must do this algebraically and you need to show your work, that would be one thing. But if I'm just saying, find the endpoint, I don't care how you get there. If this makes sense to you and you get there that way much more easily, then I would rather you get it right and do it that way and not show any work, okay? The only thing that makes this a little bit tricky is, what if I didn't give you a coordinate plane? What would you have to do? Actually, no, maybe not. Make your own planes, okay? So if I don't give you a coordinate plane, you might have to do that. So again, just to finalize, if I give you something like this, what do you have to do?
Graph it.
Draw it. Draw a graph, okay? So draw a graph. 5, 4 is right here. And that's my end point. And my midpoint is 1, 1. That's my midpoint. So where's my other endpoint going to be? Is it going to be going up or going down? Down. How do you know that? Because the M has to be where? In the middle. Okay? So then how would I figure out where it is? I'm just going to count to the right. So how many right do I go here? 1, 2, 3, 4. So 1, 2, 3, 4. And then how many down? Sorry, yes, left. And then I go 1, 2, 3 down. So then what do I do here? Go 3 down. 1, 2, 3. And then how many over? 1, 2, 3, 4. So then what's that coordinate?
-4, -2.
Good, perfect. -4, -2. Could you get there algebraically? Absolutely. Okay? So we went over 4 and then 4 more. We went down 3 and then 3 more. Okay, when do you use the add and divide? When I give you two what? Endpoints. When do you use the counting? When you have a midpoint and an endpoint. Okay. Could you also do this algebraically? Yes. You could do it the way we did it in the formulas. Yes, Mauro. Uh-huh. Because I counted that I went 4. To get from 5 to 1, how many over do you have to go to get from 5 to 1? 4. Okay. How many down do you have to go to get from 4 to 1? 3. So then you go basically down another 4 and left another 3, or the other way around. Okay, so you guys have the rest of class then to do your exit ticket. There's one problem from today. If you did not finish yesterday's, make sure you finish that one also. I want to see both of them before the end of class.